long introduction. Oh my. Okay, let me share my screen. Hi, everyone. My name is Wan Jinsen, PhD candidate, not yet a doctor. Um, the paper introduced this time is similar learning performance with different regulation process in collaborative problem-solving learning activities. And to have a quick introduction to this topic, here is the slides. To force complicated problems in the digital era, collaboratively solving problems is one important part of the workspace. Meanwhile, CBS promotes the development of learners' metacognition, collaboration, and cognitive skills. Now, however, the mere presence of technology does not necessarily lead to successful collaboration because the effectiveness of CSCL is a complex set of interactions with other variables. And to investigate how individuals interdependently regulate activities in collaborative learning to achieve shared learning goals, a concept namely socially shared regulation has emerged. For research question in this study, existing research conducted in formal face-to-face learning context has focused on the emergence of SSR as socially shared regulation. It progressed over time, results showing that group level regulation emerges more frequently in joint interaction. However, no information about the relationship between group performances and multifaceted aspects of SSR in the collaborative process, and none of them has been conducted in authentic face-to-face engineering CBS practice courses. So for this context, two research questions were proposed. The first one is what SSR group profiles can be detected based on groups adoption ratio of deep level SSR behaviors and task combination scores during authentic engineering classroom activities. And second research question is how are the SSR group profiles related to groups SSR processes during CPS assisted by CSCL scripts? For the research methods, there were 36 undergraduates from a public Chinese university participated in this experiment and forming 18 diverse groups. For the task supported by CSL scripts, students worked together to take turns being the epicenter and receiver using Internet Control Message Protocol packet. Group members were required to use their own computers to take turns being the epicenter and receiver. Challenges in these tasks including students have to face both computer operation and group management challenges. These challenges consisted of visualization, software configuration issues, operation system differences, network environmental constraints, and uncertainty in experimental data. Resource sharing and the balance of individual learning and group work also impact the task completion. The CSCL computer-supported collaborative learning scripts was produced based on the general self-regulation learning model, discussion patterns, code schemes in collaborative engineering courses by Lu, and the instructor's 20 years of teaching experience include it was mainly divided into two parts, including the planning phase and performance and reflection phase. For example, in the planning phase, the student need to think about tasks explaining and analysis to think what functions required in the task and how to what kind of design they should considered whether they have previous experience for this task. And for data analysis, we collect peer dialogue data in audio recordings and transcribe the data manually into test data. And then use SSR code schemes to label them. The coding stream from DZEC was employed as the initial version of the code scheme, and during transcription, additional SSR phases were identified. The final SSR code scheme will include orientation, planning, support strategies, and monitoring, as well as evaluation and reflection dimension of SSR, which consists of related strategies and further activities. For example, in planning in advance, we divided it into low-level planning or deep-level planning. For low-level planning, it includes activities, formulating problem-solving plan, and for deep-level planning in advance, it includes selecting problem-solving plan from multiple plans. And for the measures, for the task completion evaluation as a performance result of groups, task completion was measured in several aspects, including whether learners use their own computers, software installation readiness, the completion of subtasks, and the different detailed helps asked from other groups. And after data processing and analysis, K-means cluster analysis was performed to cluster the group SSR behaviors. K-means is an unsupervised machine learning algorithm that assigns data points to cluster centers based on similarity, which has been widely adopted. And the SSR sequential visualization for comparing the temporal flow of SSR behaviors across different clusters. Disco is a Disco software was used. It's a process mining software with the fuzzy algorithm, which is common algorithm to explore the regulation process. About the result, it was found from the airball method. It was found that three will be the optimal cluster numbers, and we can see from on the figure on the right, at the top there are two groups. So in this study, we use these two groups as an example to compare, have similar task scores, whether the regulation process have some differences. And here is one group. Is a high deep level SSR high task compilation. And for in this figure, we can see normally at the top is monitoring of a process and comprehension monitoring. And during the middle part, there are three main tests, and at the end they converge on one element. And at this one, we can see they have some different regulation process. This one is low level deep SSR and high task performance. Also start from monitoring or processing and comprehension of monitoring, but different from the appear. Yeah, different from this one. This one have a main path from planning in advance and then task analysis. After task analysis, there are main three paths to converge into the content orientation. This part, because this part almost have all elements we found we used in the code scheme. So this group was called all-round oriented regulation process group. And for discussion part, it can be different studying behaviors, different from the sequential patterns in Zaberland. We are planning followed by task understanding was the beginning. Our group regulation behaviors mostly start from monitoring phase, and the difference might lie in the task types. The CPS in Zaberland involved creating posts about a physical topic which need more discussion. This for the 38% of behaviors in share of compare and 26% of behaviors in negotiate or co-construction. Our task requires students to identify the real situation in their own computer settings according to test requirements, and then operate the ISMP packet, sending and receiving step by step. Therefore, as a testing function, monitoring phase at the beginning help the student compare and match the task requirements and their computer's real setting, and then forming operation plans for them. And prompting and
minutes, Wendy.
Yeah.
2 more minutes.
Prompting and the scanning from the instructor is necessary, especially in face-to-face CPS operating courses. CPS stimulates the inquiry process and covers related domain knowledge and operation procedures through the careful selection of authentic problems. CSSL scripts potentially scored SSR behaviors in CPS by setting milestones to help with their current working plan. Existing scaffolding to reflect on execution process and evaluating group artifacts through shared efforts. Multiply support strategy should be encouraged to help group critically reflect on the existing process and process iterated solutions. More importantly, guiding groups to realize the multiply functions of SSR would help them adjust execution rhythm within a limited time. So that's all. Thank you for your attention. Do I need to?
Thank you very much. And definitely gave us a lot of information for us to assimilate.